Hey everyone, Tim Schofield here. I can't wait for this video. I have a ton of products behind me, some that were just released. It is time to build another PC, and I have to give a big thanks to AMD for sponsoring this video and sending all of these products you see behind me over so we can build this PC and do some testing on those new products. For this build, we have 3 new graphics cards from AMD, the Radeon 6650 XT, the Radeon 6750 XT, and that high-end Radeon 6950 XT. So for this build, I don't know if you can tell, I'm excited to get this all together and put this PC together, but we will swap out and pair up CPUs with the different GPUs. And here are the pairings of the AMD CPUs and GPUs. The AMD Ryzen 5 5600, the AMD Ryzen 7 5700X, and then at that top tier, AMD Ryzen 7 5800X 3D, which includes that AMD 3D V-Cache technology. Now, all these AMD products offer great performance by themselves as hardware. However, AMD also offers software to improve gameplay even further. And the software we'll be using and testing is AMD's Smart Access Memory, their Fidelity FX Super Resolution, and their Radeon Super Resolution. And I will go into more detail on the software and how it improves, but also turn it off and on to show you how much the software will actually improve your gameplay and you'll get higher frames per second. Now, let's go ahead and unbox all of these different products and get them installed into this case right here. Let's get started. Let's begin by unboxing these new graphics cards, the AMD Radeon RX 6650 XT. Inside, just a quick booklet. Taking it out of the packaging reveals that design with the triple fans. Now this GPU has 8 gigabytes of VRAM and 32 megabytes of Infinity Cache. Also want to make note that it has an 8-pin connector to the PSU for power, and when it comes to connections into your monitor, 2 HDMI and 2 display ports. And taking the Radeon RX 6750 XT out of the packaging, here's a look at the design. Very similar overall. Again, make note of the design of all of these, the form factor with that 2.5 slots, triple fans, fits in most cases, and then make note of that thermal design and airflow to keep the GPU cool. Now this specific GPU has 12 gigabytes of VRAM, 96 megabytes of Infinity Cache. It also has a 14-pin slot to connect to that PSU and the same connections to the monitor, 2 HDMI, 2 DisplayPort. And on to the big one, the AMD Radeon RX 6950 XT. This one is from ASRock. Just a quick look at the back of the box for you, showing off some of the features that this GPU has. Inside the box, you have a graphics card holder if needed. You also get a booklet. Taking it out of the plastic, definitely bigger than the other two overall, but again, same triple fan setup. This 6950 XT has 16 gigabytes of VRAM and 128 megabytes of Infinity Cache. Pretty crazy. Also want to point out on all these, the RDNA 2 architecture for power efficiency. You get up to 65% more performance per watt over just the original RDNA. And in terms of power, 24 pins to connect to that power supply overall. So yes, obviously the more power you get out of these GPUs, the little bit more power it's going to require. When it comes to those connections to the monitor, 3 DisplayPort and just 1 HDMI. Here are our 3 processors we will be pairing with the GPUs. The one I want to point out, do an unboxing of, is the Ryzen 7 5800X 3D processor. This is actually the world's fastest gaming desktop processor and the first desktop processor to feature AMD 3D V-Cache technology. And for an idea of the other products, we are using the ROG Strix X570E gaming Wi-Fi 2 motherboard for our build. Installing the CPU, very easy to just drop in and lock in place into the motherboard. We'll be using Corsair Vengeance RGB RT RAM. We've also got a Corsair MP600 M.2 SSD that we will be installing. To keep the CPU cool, the ROG Ryzen 2 240 liquid CPU cooler. We'll be using the Height Y60 case. Pretty excited to check this one out. And then the ROG Thor 850 watt power supply. Now that our motherboard's screwed in, our CPU cooler's all connected, everything's just about ready to go. Let's install that GPU. And now keep in mind, with this full AMD platform with an AMD CPU and GPU, they work very well together with Smart Access Memory. So what exactly is AMD Smart Access Memory, also known as SAM? It's a platform solution that lets the CPU access the entire memory aperture of the GPU, leading to some pretty significant uplifts in performance. This feature works on all Radeon RX 6000 series GPUs when used with the Ryzen 5000 series CPUs and select Ryzen 3000 series CPUs. Now, I will have SAM enabled throughout all of my testing today, and also worth noting, if you have a GPU CPU pairing that I just mentioned, you have to actually go into the BIOS to enable it, or if you plan on purchasing one of these combos. To enable Smart Access Memory, fairly simple. Once you're in the BIOS, go to the Advanced tab, and then find the PCI subsystem settings and allow 4G decoding, and then resize bar support. Select Auto. Then go to Boot, and make sure Launch CSM is disabled. And once you've done that, you are ready to go. Just go ahead and reboot while saving. If you don't see these settings, you might have to update your BIOS. It might look a little bit different depending on your motherboard. So now that we have our build and all our configurations in place, we are going to do our testing with two different games, Assassin's Creed Valhalla and Horizon Zero Dawn. And in recent years, upscaling has really been widely requested by the community, letting gamers run their games at lower rendering resolutions and use intelligent algorithms to upscale the images back to the native resolution of the display, allowing for performance enhancements, including higher FPS. AMD actually offers two solutions for upscaling technology. The first one being AMD Fidelity FX Super Resolution, also known as FSR. It's an open source cross-platform upscaling technology, which is already supported or coming soon in more than 80 games. You don't need any special cores or hardware in the GPU to use it. It's incredibly easy for the developers to integrate it, so hoping to see more and more developers take this open source platform and integrate it into their games. And with FSR, gamers can get up to 2 times more performance in the latest titles. So we're going to be using Horizon Zero Dawn to actually test out FSR. Now, not all games have FSR, so for the ones that don't have it natively, AMD has Radeon Super Resolution, also known as RSR, to implement into games that don't have it. Now, this is a driver-based version of FSR that can be enabled globally in the Radeon software on your computer. It works across thousands of games. To enable it, you just need to turn the feature on, lower your in-game resolution, and RSR will take care of the rest to upscale it with that upscaling technology. So let's check out our testing and some of the results we got in terms of frames per second running these games natively, and then turning RSR or FSR on with SAM enabled for that full range of performance uplift. We're gonna start with the AMD Ryzen 5 5600 and the Radeon RX 6650 XT combo and work our way up. Now, I'd like to call out, we are gonna use the highest graphical settings, so you could even bump down the graphics if you want to and get even higher FPS than what we're doing with this testing. And then also wanna make note that with our different combos of CPU, GPU, we're gonna go from 1080p resolution gaming all the way up to 4K. So this is a 4K monitor behind me. We're gonna take full advantage of that with that higher end config. So just wanted to call that out because you're gonna see similar frames per second with each combo, but obviously when you think about it, running a game in 1080, you're gonna get much higher frames than if you ran it in 4K. So just keep that in mind throughout our testing. Now, after doing my benchmarking, which obviously included a lot of gaming, a lot of fun, I got an average frames per second while playing. Now, natively, the average frames per second was 99.6, still very good performance. And then turning on that Radeon Super Resolution within AMD's software, I bumped it all the way up, that's all I did, to 126.4 average frames per second. So you'll see a significant difference there. And then booting up Horizon Zero Dawn, same thing. Played a lot of it. It's actually, both of these games are a lot of fun. And natively 103.1 frames per second average. And then again, all I had to do was actually go into the game settings and turn on that AMD Fidelity FX super resolution. So you don't even have to do it through AMD software. The developer implemented it in the game settings. Get this, it bumped it up all the way to 141.3 frames per second. So going from 103 to 141 frames per second makes a significant difference, specifically if you have a higher refresh rate monitor. On to our next combo of AMD GPU and CPU, installing them, the AMD Ryzen 750-700X, plus that Radeon RX 6750 XT GPU. And again, keep in mind, doing that testing in 1440p on this monitor now, so bumping it up from that 1080p of the previous config. And same process of testing, just doing a lot of gaming with these games. And with Assassin's Creed, our base native FPS was 88 on average. And then, of course, turning on that RSR, it bumped it up to 117.1. So again, a significant bump in that 1440p gaming. And while doing our testing with Horizon Zero Dawn, same type of results. Our native resolution at 104 frames per second. Again, still very good. But then turning on that FSR in-game, you get 139.2 frames per second on average. It's just kind of incredible how well this actually works. And on to our final testing. I'm sure you've been waiting for this one. I know I am very excited to test out this combo with the AMD Ryzen 7 5800X 3D CPU and the new Radeon RX 6950 XT GPU. Very excited. And again, this is going to be 4K resolution. So again, you could maybe even bump down the resolution if you'd like to and get even more frames per second. You could bump down that graphics quality if you want to. I'm excited to see what kind of results we get. So again, starting with Assassin's Creed Valhalla in 4K, these two games look so good in 4K. So the average frames per second after gaming with Assassin's Creed is 78.8 frames per second natively. And then turning on that RSR, we get all the way up to 97.4 frames per second on average. So you're almost getting a 20 frames per second bump in that 4K gaming, which is kind of wild to me. And last but not least, our testing with Horizon Zero Dawn with that FSR integrated into the game. So native frames per second was 82.8 on average, which again, still very good for something that looks so good in 4K. And then just flipping the switch in the settings, turning on FSR, you get 127.5 average frames per second. And again, I played quite a bit of these games, doing a lot of testing, doing the same missions. It's nice with a single player. I can do the same ones, get an average FPS, just multiplying them all together, dividing them by the amount of times I really tested all of it. And after playing it for so long, pretty cool to see the insane jump in frames per second. I mean, I was hitting, over the average FPS at certain points in the game, which again, gaming in 4K 144 hertz monitor, you can really take advantage of it when you use this software. And again, it's on top of using SAM with the combo of the AMD CPUs and GPUs. So now that our testing is done, I want to give some final thoughts and just talk about my experience while doing all this testing. First of all, thank you AMD for supporting the channel, sponsoring this video. It's been a lot of fun to make, allowing me to do my own testing, getting my own average frames per second. Because honestly, if you think about it, AMD has their Ryzen CPUs, the Radeon GPUs, and those advanced technologies such as Smart Access Memory, Fidelity FX, Super Resolution, and Radeon Super Resolution. It's also very clear through my testing that these new Radeon RX 6000 series graphics cards for 2022 offer higher performance than last year's models through that faster GDDR6 memory, higher clock speeds, and process improvements, which gives you that higher frame rate, allowing you to play games in better graphics qualities and even at higher resolutions. And also, it was really great to test that new Ryzen 7 5800X 3D processor. Actually, if you want to get really technical, it's the first desktop processor with stacked L3 cache with an unmatched 96 megabytes of L3 cache. Kind of crazy. And then when you compare it to AMD's Ryzen 9 5900X, you get an average of about 15% faster gaming. So really cool that AMD's pushing the edge of this technology and just allowing you to really take advantage of these high-end games and giving you the best performance you can. And it's no secret, it's been difficult looking for parts if you're looking to build or upgrade your computer. And actually AMD sent this over. I wanted to actually read it so that you hear it from them themselves. And market conditions are trending toward a healthier state for gamers. We expect the accessibility of new graphics cards in the channel to continue to improve, which makes this a perfect time to provide new, higher performance options for gamers that have been waiting to upgrade. So that is nice to hear. A positive ending, hopefully, to this trend, and hopefully it continues to be more and more accessible for everyone. I know a lot of people that have been waiting to upgrade just because they couldn't get their hands on last generation's products. So now, hopefully, we start to see more and more accessible options. And, you know, in my opinion, this is a great option. AMD offers a lot of benefit when you're combining their hardware with CPUs and GPUs, because then they can access that and add those performance technology upgrades, including that SAM, FSR, RSR, all that good stuff that comes with using AMD products together. So anyways, I hope you enjoyed this video. I had a lot of fun making it, a lot of work building the computer, doing all of this testing, a lot of gaming that went into it, a lot of, you know, the math, getting the average frames per second. So it was a lot of fun. I hope you enjoyed it. Be sure to subscribe. A lot more content coming soon. Be sure to give this video a thumbs up as well. Drop a comment. Let me know what you think. As always, thanks for watching.